Alrighty, welcome back everybody. It's your main math man, Mr. Shen, coming to you live from Summit Academy. In this video, talking about writing some polynomial equations. Again, in the previous videos, we've kind of talked about how we can find the degree, the end behavior, the leading coefficient, what the sketch looks like, and be able to kind of draw what those things are. So for the first one, it says for the warm-up, it says sketch the graph of the following polynomial. So we're talking about multi-term equation. Again, polynomial means multiple terms. So I have f(x) equals negative 2x times quantity x minus 3 squared, and then 2x plus 4. So what I can do here is actually sketch out my x-intercepts. I can also use the graphic calculator right away, but I can also follow these steps. So I'm going to say, okay, well, I have the negative 2x by itself. Since I don't have anything plus or minus, that means it just goes through 0, 0. So I'm going to graph out one of my roots, meaning x-intercepts, solutions, zeros, or, yeah, just those four, x-intercepts, roots, solutions, zeros. There it is. So I can graph out the point 0, 0, because I know it goes through the x-axis at that point. I can say I have a double root at x plus equals positive 3, because I have an x minus 3. So that's going to tell me I have a double root. I have 2x plus 4, which on the side, if I needed to do it, I can do 2x plus 4 equals 0. Subtract 4 from both sides. And I'd say I have 2x equals negative 4. Divide both sides by 2. Divide both sides by 2. I get x equals negative 2. Alright, so if I wanted to, I can calculate these pieces on the side, but also let me actually pull up my end behavior table. So here's my end behavior table. Again, we have a leading coefficient. Let me check back what our degree is. So we have a negative leading coefficient because we have that negative 2 in the front. And I have 1, 2, 3, 4 x's, so my degree is even. I'm going to say, okay, I have an even degree and a negative exponent, so I should have an M shape. So when I'm sketching this out, I kind of know what I need to do. So that just means this, so I have at the far left tail, it goes down to the left. At the far right tail, it goes down to the right. At negative 2, it goes through the x-axis. At 0, it goes through to the x-axis. And then at 3, 0, it actually bounces off the x-axis, which is why it has that M shape. So I should be able to, make some decisions on that. Again, I can say my leading coefficient was negative 2, which is negative. I said my degree was 4, which is even. So I can just make notes, about my equation or my curve, just by looking at the equation. So I should be able to get some information from that. And follow those steps that we wrote out in one of those last videos. I think it was maybe lesson 4. But whichever one it is, I can write out or maybe it's 3. But I can write out those steps on how to graph out my polynomial equation. So I can, find the degree, find a leading coefficient, find the end behavior, plot those x-intercepts on the graph, sketch the end behavior, and then sketch the curve. All right, well, what we're doing today is going to be writing those polynomial equations. So we're going to create, students will, in writing, create equations for polynomial functions with the roots and using a language of math. So what we can do here, we're trying to figure out, okay, well, what is the equation look like if we're maybe given the graph? So a couple different forms, we want to always be able to switch from, a couple sentences or those ordered pairs in a sentence, or you can go from the graph to the equation, or vice versa, or we go from the equation to the graph, which is what we did in the warm-up. But in this one, it says replace the hashtag symbols or the number symbols in the row 1 function to match the graph given. So we have a dashed line on this curve here. So we're trying to figure out, okay, what are going to be, what's going to be the equation that goes through these points? And we can actually check to see, hey, does it actually match up? So let's figure out, where do we have it? So I have one of my x-intercepts is at -5, which is why there's a x plus 5 here. My other x-intercept is going to be at -3. So what I'm going to say here, instead of plus a number, I'm going to say plus 3, because it actually graphs out and it goes, through. If I have the point on the graph, I should take the opposite for the x value. So if I have my x-intercept on the graph, it's -3, 0. I know it's an x-intercept because of two reasons. It goes through the x-axis, the curve where there's the point where the curve hits the x-axis, and it's where y equals 0. So that's an easy way to be able to figure out, hey, where my x-intercepts are. Then it has, moving along on the function, I have x minus 1 in my equation, which means x plus 1 on my graph, or x is plus 1 on my graph. So it's a little bit harder to see, but I can find those points. And then for the last one, I have a blank here, so I need to say, well, what's in between 4 and 6? It should be 5. So I'm going to say, scroll up a little bit, too far. I'm just kind of dragging points on my curve, so I can say, hey, that point 5, 0 would match up with the x minus 5 in my equation. So notice how as soon as I graph it out, it goes through those points. So I can check, I can click and make sure, hey, the dashed line matches up with the solid line. Also, too, if I'm unsure, I can change anything I want. So maybe I thought there was a negative in front. Notice how big of a difference it makes on your graph. So even though I, have that it goes through those x-intercepts, it changes the shape entirely. Or maybe I thought this was a -5, and notice how it changes my graph entirely again. So, I could get some of those x-intercepts right, but I have to make sure that each of them are exactly like I need to do. So, my equation for this curve, for this dashed line that I now have covered up by a solid line, is f of x equals, in parentheses, x plus 5 times x plus 3 times x minus 1 times x minus 5. So it should be super easy. Again, this is that factor form, like we said, where those values inside of the parentheses are opposites of your x-intercepts. All right, so that's exactly what I'm saying. To find that that equation of a polynomial function, you can use that math. Again, first I'll write all those x-intercepts, meaning roots or zeros or solutions. Again, it can take that list of values like that in parentheses, and then we can pick an additional point on the graph to substitute in for x and y to solve for a. So this should be familiar to you because we did this in the semester 1 class and in math 2 as well, where we're trying to figure out what's our leading coefficient, which if we have our general form of our equation, where we come up with what that is. Again, previously you solved it in vertex form or in an intercept form, but same thing. We should be able to still solve for a. But we'll work towards that point. So it says, try this. It says, identify the x-intercepts of the polynomial. It says, check the correct boxes, and I can select all that apply. So what are my x-intercepts for this? Well, I click the curve, where my x-intercepts hit the graph. Again, a lot of people are going to be clicking extra points and they're thinking, oh, well, all these are x-intercepts. No, that's not the case. You have to make sure it's wherever y equals 0, not where x equals 0. That's a y-intercept, but where y equals 0. So notice how all my choices have 0 in them. So I'm going to have a 0 in the y place. So I'm going to say it's going to be -3, -1, and +2. Oops, sorry, +2. Let's check it out. Yeah, they're good. So make sure, I have 3 x-intercepts, so I have 3 roots. All right, so let's find another point on the graph. Let's just use that x-intercept like we had. So I could use other points that are on here, but it can't be another x-intercept. So I'm going to just say it's going to be at point 0, 3. So it could be an additional point. You could also use, I think, negative 4, 9 on here. Yeah, you could also use negative 4, negative 4, comma 9 on there as well. That's an additional point. I think that was like the only one. But, you know, if you wanted to check out other points, you could. But I'm just going to use this one for right now. All right, so now let's put it all together. So I need to actually put that poster on Schoology, but what you can see is I'll have an example on there as well. And I think it's actually this example, but let's try it out. So let's put it all together. So what we're going to do is let's write out that general form. So we're going to say it says using point and x-intercepts. You can substitute them in the equation and solve for a. So I need to go back and actually find out what those x-intercepts are, but it's going to look like this. I'm going to have f of x equals a times x minus b times x minus c times x minus d, so on and so forth. You know, again, depending on how many x-intercepts you have, you need to make sure that you are including them in your equation. All right, so we said our x-intercepts are at -2, -1, +2, -3. Okay, if you want to put them in order, it doesn't really matter. I can say it like this. I'm going to say, okay, now so this is general equation. Now let's substitute in those x-intercepts. So let's do a different color here. Let's do half white. So let's substitute in those x-intercepts. So I have f of x equals, I don't know what a is, but I have it goes through, we said -3, -1, +2. So there's -3 in my point. I have, let me get it a little bit closer. I have x plus 3 in my equation. Since it's -1 on our graph, we have x plus 1. Again, take the opposite of those x-intercepts. And then if we have plus 2 as our x-intercept, we have x minus 2 in our equation. So I substitute in, let's just say substitute opposites of x-intercepts. All right. Next step, we have to enter in that additional point. So let's use that y-intercept that we had. Or if you wanted to, maybe if you want to challenge, I would say you can change this point to be 4, it's -4, 9. If you wanted to, challenge, try that one out and do it like that. So either one works. But let me actually keep it how it was just for right now. Actually, no, it's fine. I'll do I'll do the harder one. So let's do -4, 9. Let's just do the harder one, just so we have different. I think in the example I did, I used 0, 3. But as long as you have a known point, I highly recommend not using decimals. But you find a point that is along the curve and plug it into your equation. So that way you're replacing it with integers, meaning those whole numbers. So I'm going to say, let's do green now. So I'm going to say, let's let x equal -4 and f of x equals 9. Okay, so in my equation, anywhere where I have an x, meaning on that right side, I'm going to replace it with a -4. And on my left side, where I have an f of x, I'm going to have +9. So I replace, let me say, replace, let's say x comma f of x. So I should be able to, substitute that in. So it's going to look like this. I'm going to start out with a 9. A lot of people, this is where they make the mistake, is they just plug in those numbers, but it has to be you know, just where those numbers are. So since I start with f of x, that means I start with 9. So I say 9 equals a times x. Nope, just kidding, not x, negative 4 now. So I say negative 4 plus 3 times negative 4 plus 1 times negative 4 minus 2. So it's exactly like my previous line, except notice how when I substitute in that extra point, I only have one variable remaining, which makes sense because I'm trying to solve for that exact variable. So I'm trying to solve for a, that means I should have a only as my only variable in my equation I'm trying to solve for. All right, now let's say this. Let's say I want you guys to save yourself some calculations here. That entire right side, except for the A, key part here, you can't type in A because you don't know what it is. But what you can type in is those sets of parentheses. So let me write this. Let me say type in Desmos those sets of parentheses. So it's going to look exactly as they look. So I'm going to say parentheses negative 4 plus 3. Again, be very careful when you're typing these in. Make sure it's exactly what it needs to be. So I have negative 4 plus 1 times negative 4 minus 2. So what it's going to do is it's going to calculate that right side for you. And a lot of people are, hey, that's my answer. Not quite. All I did was I typed in that right side that I underlined. So those 3 sets of parentheses are going to be equal to negative 18. So that's what I'm going to write underneath. I'm going to say 9 equals a times negative 18. All right. Really simple now. Again, I'm type that into Desmos. I have to now divide both sides. Let's say both sides by that number. What I mean by that is whatever number you get, I'm trying to solve for a, so it's currently multiplying. I have a times negative 18, which means I have to divide both sides by negative 18. So let me probably should have changed colors there, but that's okay. Yeah, let's just do negative 18. Try it again, negative 1, 8, negative 1, 8. What I suggest you do, I'm not going to take off points if you tell me it's a fraction. So if you want to, I'd say this. Leave a as fraction. So I'm going to say a equals negative and then 9 over 18. Okay, notice how I'm not circling that as my answer. My last step is this. I'm going to say over here, let me say substitute. It's not working with me. Substitute. There it is. Substitute a into original equation. Oh, hold on a second. All right, I think we're still good. Okay. So it says substitute into the original equation. All right. So what I'm going to do is I'm going to take that value that we found for a, plug it back into our original equation up here. So my final answer is going to be this. I have f of x equals negative 9 over 18 times x plus 3 times x plus 1 times x minus 2. This is going to be the equation that we get for our final answer. And what I can do is, when I type it in, I can check to make sure it goes through those points. So let me actually show you what it looks like on our graph here. So I'm going to leave it as a fraction. That way I don't have to worry about any calculations. If you wanted to reduce your fraction, you certainly could. I'm not going to take off points. But for right now, I'm mainly focusing on this. So I copy my answer, or copy my equation, I should say. And what I need to do is I need to make sure it goes through those proper points. What I mean by that is, okay, where are my x-intercepts at? -3, -1, and 2, 0. Those were my starter points. Does it go through my extra point of -4, 9? I don't see it, but I can zoom out, and if I look, notice how it goes directly through it. As I zoom in, it's not like it's getting further away from that point. It's actually just still directly through it. So notice how it goes through that point. Same thing with my additional point that, like I said, I can check the additional point of 0, 0, 3. Notice how it still goes through that point as well. So what I can do is I need to actually, let me write this too. If you're able to fit space in here, awesome. If not, that's okay too. But I would say graph on Desmos to check, let's say, points. I don't know why it's a little laggy, but that's okay. So there's our points for that. Let me actually put this under here, maybe. Second. Give it some air. Doesn't hate me. Okay, let's try that. All right. So what I have to do here, again, find your general equation, substitute your opposites of your x-intercepts, replace x comma f of x, meaning your extra point, type that right side into Desmos without the a, divide both sides by that number, leave it as a fraction, substitute a back into your original equation, and graph on Desmos to check those points. So that's going to be our equation all together. All right, so I know that took a minute, but I wanted to make sure, we show it step by step. I wrote each of those steps down. So I'd say, make sure you take your time. If you need help on, what any of those say, make sure you ask questions. I'll be able to help you out. Okay, let's move on. All right, so does your equation line up with the orange equation? I don't see an orange equation or an extra point here. I can actually show maybe we messed up and we thought this was positive, like we didn't type in the right equation. So if I check the next slide, notice how it's not graphed in there. But we graphed it out. It should just say dashed line, but that's okay. We're just mainly looking at, hey, does this work out for our graph? Which it does because they overlap. So it's a key part here with this is I know this equation is right because it overlaps with my original equation. Okay, so let's try it out. So now let's try our strategies here. So identify those x-intercepts. I have two x-intercepts. One is at -2 and the other at +1. All right, pick an additional point. Let's use the x-intercept this time. So let's say 0, or let's say the y-intercept. I can't use the x-intercepts, but I can use the y-intercept. So I'm going to say 0, 1. All right. Now let's graph out those equations. So let's come up with our general equation. So I have f of x equals, I don't know what a is, but I actually have to, let me go back to my points here. The key idea is I have to have, and make sure I mention, I have some double roots here because it bounces off that x-axis. So I'm going to say I have a double root at x plus 2 because it's x equals -2. And then I have a double root at x minus 1 because on the graph it is +1. Triple check. Yeah, so I have double root at -2, double root at +1. All right. So that's going to be my general equation for right now. So I plugged in my x-intercepts. Now I can have my additional point. So I said, let's let my additional point be x equals 0 and f of x equals 1, because that's our additional point that we found on our graph. So that's 0, 1. All right. So I'm going to say on our equation here, I'm going to say f of x equals 1. I have a times 0 plus 2 squared times x minus, or sorry, not x, 0 minus 1 squared. A lot of people end up making mistakes like this because They see me plug in 0 and they think they can do 0 all the time. That is not the case. It is specifically whatever the extra point is. So you have to be paying attention. Is it x comma f of x, or whatever the value is. You have to just be mindful of those points. Hey, what's up?
Can I get a loaner for June?
Okay, so let's plugged in our additional point. So let's simplify. So I'm going to say, like we said before, I'm going to say type this into Desmos exactly as it looks. So I have in parentheses 0 plus 2 exponent 2, and then 0 minus 1 in parentheses squared. So that's going to all be 4. So I'm going to say in my equation, I have 1 equals a times 4. So I should be able to kind of simplify that right side of that equation. Make sure you don't type in that a. Again, notice what I box off. I only box off those sets of parentheses because I'm trying to figure out, when those multiply out, what those calculations are. Last step to get a by itself, divide both sides by that number we just found. So I divide both sides by 4. Leave it as a fraction. So I say a equals 1 over 4, which we can plug back into our original equation, which is all the way up here. And I'm going to say, all right, here's my original equation. Again, practice writing it out, but I have f of x equals 1/4 times x plus 2 squared times x minus 1 squared. Let's make sure we graph it out. Type it in exactly like it needs to. And make sure you're checking your work as you go. That way you can make sure your answer is good before you submit it. All right, graph it out on Desmos to make sure it goes through my additional points. So I make sure it goes through my 2 x-intercepts, the most important thing, but we have to make sure it goes through that additional point of 0, 1. And so what I can do is I can always graph out, that additional point first to make sure it goes through that additional point. So if you want to, certainly could just type it out in parentheses, click that label button to be able to find where it's at, and zoom in or zoom out if you need to. But I know this is right because it goes through that additional point and it goes through my x-intercepts. So let's see on the next slide, does it look good? Yes, it does. I don't see any difference between the dashed equation and the solid equation. And then for the last one, I want you guys to try this one out on your own. It says, show me your knowledge. Write an equation that has x-intercepts at 2, 0, 3, 0, and it has a double root at negative 3, 0. And we could say the equation also passes to the point 10, 10. So make sure you're following the steps like I said before. Again, we have those, find your general equation with your x-intercepts, take the opposite of those points, and to find out where your equation is, again, it has a double root in it, so make sure you have exponent 2 on that set of parentheses of x plus 3. And then also to plug in that additional point, 10, 10, really easy to plug in, so make sure you're checking that out. Make sure it goes to the graph, find what a is first, but then make sure you can check that original equation. Be sure to ask questions, and as always, super slap that subscribe button.